Dr. Adeola Olubamiji is now with Desktop Metal, and she has some really wonderful insights to share with us about building up a career ladder in a brand new industry, which is. So Addie, welcome to the stage. The floor is yours.
Thank you very much, Sarah, for having me. I'm very excited to be here. Hi, everyone. I hope your day is going well. I don't think I can top the last presentation, but I will try my best. I'm trying to get my screen ready, and we will get started. All right, I hope you can see my screen. And I want to tell you this. My first disclaimer is I am not in HR, so you're not hearing from an HR expert. I will tell you a bit about myself. My name is Adeola Olubamiji, and if I will describe my career path, I have a Bachelor's of Science in Physics from Nigeria, headed to Finland, where I got a Master's of Science in Biomedical Engineering. And then from there, I moved to Canada, where I obtained a PhD in biomedical engineering with a focus on additive manufacturing and synchrotron X-ray imaging. I worked in Canada for a few years, so my journey in additive started during the PhD, focusing on biomedical applications. I went from there, from polymeric biomedical applications into metal additive manufacturing, focusing on aerospace and space applications. A couple of years later, I moved to Columbus, Indiana to take a job, still working in the metal space, but focusing on automotive applications. Right now, I have switched gears again, and I am with an OEM, so still working in the metal space. Over the last 10 years, I've seen my career transition from polymeric to different types of metal applications. So I've gained a couple of experience from laser powder bed fusion to direct energy deposition to binder jetting. I have come here to tell you a bit about my experience when it comes to filling the talent gap that we have in our industry. This is not something that I put together to make us feel like we're not doing a great job. So it's a conversation. So I'm expecting that you ask questions and that we kind of just think about where we are and where we need to go as an industry. So, as we all know, additive manufacturing is part of the Industry 4.0 technologies. It's exciting to be one of the innovators and the people who are going to move the world forward over the next 50 years. So we're not alone. Additive manufacturing is not the only areas that is experiencing that talent gap. All of these other technologies are also experiencing the same thing. While that is very cool to talk about, additive manufacturing is manufacturing. So there are some constraints that we have to keep in mind because it is manufacturing. The first one is millennials, who are the people focusing on Industry 4.0. They're oftentimes having that negative connotation and the perception of manufacturing as being dirty, cumbersome, extremely time-consuming, and maybe a little too hands-on. In the manufacturing industry today, there is that employee vacuum, skilled employee vacuum that is looming as aging and retirement are really catching up with that industry. We also notice that even for additive manufacturing, that there's a disconnect between the industrial needs and the skill sets that new graduates of additive manufacturing are collecting. So maybe they get about 50% or 60% of what is required in the industry, and the industry can't wait. We want people who come in and hit the ground running from the day one. It's hard to get that new graduate to do that because their master's degree was focused. So how do we then help with this talent gap that is right there and confronting all of us? First of all, I want to talk a little bit about the difference between additive manufacturing and manufacturing that has served as a bottleneck affecting all of us. One of them that I have seen a lot is the manufacturing hierarchy and culture. The conventional manufacturing hierarchy and culture rewards people based on how long of experience they have within the company It rewards people based on the structure and hierarchy that we have used for over 100 years. But because additive manufacturing is part of the Industry 4.0 areas, younger people are looking for performance-based career ladder, performance-based career growth. As we know, this is a new technology, and we don't have a whole lot of people with 30 or 40 years of experience. How then do we hire a director or VP of additive manufacturing if we don't have people with 30 years of experience to fill the space? Are companies willing to let young people lead? That is the simple way that I'll put it. Are you willing to let a young person lead your team when you're trying to start a business when it comes to additive? When a large manufacturing company is trying to adopt additive, are you letting young people live? This is one of the reasons why there is that disconnect and that strive that has continued to lead to talent gap. Another way that is confronting all of us right now is the manufacturing pay scale versus additive manufacturing pay scale. Additive manufacturing is part of the Industry 4.0 technologies. People who go to school to study this are expecting that they get paid in the additive manufacturing, in the Industry 4.0 kind of pay scale. For the manufacturing pay scale, statistics has even shown that the pay in the manufacturing industry is actually declining. So if then the pay is declining, how do we attract young people to come into our industry and who have acquired this additive manufacturing skills and they feel like they're worth more? They want to be paid similarly to somebody who had studied blockchain, somebody who has studied artificial intelligence. How do we manage that disconnection that we have today? The last one that I have seen often is the expectation of companies when there is advertisement of roles. Usually we expect the people to come in with all of the skills. We expect them to have design skill. We expect them to have process engineering skill, sometimes to have business skills, other times to have GD&T skills. Is that possible in one person? How do we manage our job descriptions? How do we manage stacking up the right people in places for additive manufacturing adoption? These are some of the questions that has made it a little tough for our industry to really position the right talent in places and really get them to work and also grow our industry. I put a picture here to showcase something that I found online. They were talking about the additive manufacturing workforce, and they had some soft skills on the other side here. And on the right side, they have some hard skills that is expected that maybe every additive manufacturing engineer has. It is expected that you have some design for additive manufacturing knowledge. It is expected that you have commercial knowledge, that you have experience with vertical markets, that you even have a whole lot more when it comes to different additive manufacturing technologies. We should ask ourselves, how possible is it that one person have all of that? Usually a process engineer may have little to no knowledge of design. If we keep putting criteria that make it hard for people to get hired on our advertisement, how then do we find the right employee? How then do we really grow our team? So let's talk about how are we training this workforce? Who is training them and who is really recruiting them? From my perspective, universities are trying their best today. Additive is so new, and during my research, I have not come across a whole lot of universities who have bachelor's degrees that focuses on additive. We have found a few of them that have master's degrees or certificate programs focusing on some specific areas of additive. We have also seen research centers coming up with different strings of training programs for people who are interested in this technology. One of the biggest bottlenecks is what then should a university include in their curriculum, in their programs, to ensure that they deliver people that can come into the industry and really hit the ground running. As of today, I do not have a clue how the universities are conversing with the industries to know the needs of the industries. When we look at the industries, additive manufacturing technologies cuts across 7 major technologies. We have tons of sub-technologies under it. How then does a university know which type of technologies should they try to ensure their students are getting knowledge on? All of this makes it a little tough, as each of those technologies in additive requires specialized skills. Each of them, when it comes to their processes, require that you know some details. So if somebody has gone to a university that has binder jetting and learned everything about binder jetting, now if they're looking for a job, will a position on laser powder bed fusion be appropriate for them? Will a position focusing on polymeric material development be appropriate for them? How do we want to bridge this gap? Because it is affecting our industries. All right, here are some of those questions that I want you to keep in mind. I want to talk about another thing that I have seen. When it comes to adoption of additive manufacturing, companies are excited to take this technology. They think it is the future, and most companies are trying to really get into it and get started. But the understanding of how does technology development, engineering, and technical, how does it fit with manufacturing has been a bottleneck. Most companies get into this technology getting excited about the value proposition that design for additive manufacturing brings. They get excited about the technology possibility, the degree of freedom, and all of the good stuff that we have. They get excited about some cost modeling that showed that they can reduce their cost drastically. But oftentimes, we don't think about the workforce. Who do I need in my planning phase? When then do I need other people? Who do I need in my scale up manufacturing validation phase? How do I overlap these needs? If you're a company owner, if you're an adopter of this technology, I want to encourage you today that you put a people roadmap together the same way you are putting a development roadmap together. How many technicians do you need for the different phases in the technical development? How many engineers do you need? What type of engineers are they going to be? What is your hiring process? Are you planning to collaborate with a university to source the right people? Let us make that plan, because not making that plan is not helping the industry really do well in terms of raising champions who can fill the position that could be open in your company when you switch from technical development to real manufacturing. As someone who has been in this industry, I have seen the dilemma of not having enough people to kind of go around. Companies try to get who they can get, try to talk to people because there are few experts. Some of you who are listening to me today, you're subject matter expert. I have a few questions for you. And one of them is that, who are you mentoring? Who are you talking to? What university are you supporting for them to be able to grow the right talent that will fill the space in our industry? Growing our industry is not just a job of the university, it is our job collectively as people. Now, how do we expand the pool that is currently very limited? Here are some suggestions that I put together for us. We need to expand the pool, and that is where I'm going to start from. I want to talk to universities directly at this point. To expand the pool, we need to graduate and train the right people so that when they come out of the university systems, they have the right skills. They just don't have 2 or 5. They have the 5 skills that they need to be able to hit the ground running outside in the labor market. I want to admonish universities to open up more adjunct professor positions, focusing on industry recruitment. Recruit subject matter experts from different companies to come and work within your lab to help you offer the right criticism, to help you mentor the students within your program. I feel like doing that will help us understand the need of the industries and train those students appropriately. I also would encourage that we just don't focus on engineering, that technicians also need mentors. Technicians need the right training. When we talk about additive manufacturing, we focus a whole lot on the engineering track and continue to leave the technicians behind. This is the time when we really think about them. What are we providing technicians? They don't get master's degree. Do we have programs that are appropriate for them? Those programs, are they available for them? The work culture is the second one. As people within industries, as people sitting on boards of different companies, I want to admonish us that we will try to help additive manufacturing actually get a good propagation within our companies. We will try to work on transitioning people's mindset about what it is needed when we're working in manufacturing. Additive manufacturing thrives when we collaborate. Additive manufacturing is here to provide improved digitization. It is going to be data driven and there will be real time development. I want to admonish us that we will be open to that work culture change because this is the only way we can get retention and expansion of additive manufacturing within the companies. Pay scale and career progression. This is very important for additive manufacturing engineers because it is time for us to kind of think about what are we using to determine how much people get paid. Our industry is so new. There is no roadmap. There is no plan. Every company just come up with what they think is appropriate. What is appropriate for your company, another company may be willing to pay more. There has to be some sort of standardization. We're working on standardizing our processes. We're working on standardizing different materials. Let's also try to work on standardizing career progression at the pay scale, because without having that, our industry will suffer. Hire to train. I know you want those people to already know everything because you are also new to the industry. But hire to train will be a good thing for your industry on the long run. You may get one specialist who is now allowed to mentor 10 people or 15 people within your company, but you have to be open, and we all have to be open to hiring to train. The last one, and one of the most critical ones, is AHEM adoption roadmap. Adopting AHEM is not all about designs. Adopting AHEM requires more than that. As you go on your journey into industrializing and adopting AHEM, I hope that your roadmap will include managing the people, include understanding of what is needed to not only hire, but to retain the talent. And I hope that your roadmap will understand that one person cannot do 16 roles, that more people is required than one, even if you're in the beginning phase of your additive journey. Well, I must tell you, this is all I have for you. And again, I'm not an HR specialist, but I share this from my experience and what I see as some of the ways that we can increase the talent pool and help our industry grow. Thank you.
Thank you, Addie. That was wonderful. And if the chat and Q&A are anything to go by, I think people are really excited to hear what you have to say. And definitely we've got some good questions for you already. Okay. And if you're joining us live, there's still a few minutes to put in more questions that you want to know, and be sure to upvote the ones you most want to know. So right now, Addie, our top voted question that people want to know is, what in your view are the top 3 most important digital transformation skills that you think the workforce needs right now?
Okay, the top three. All right. So one of them for me right now is data analytics. When we look at how we work in additive, tons of data get generated from the design phase to even when you're done, you have your build logs coming out. For us to understand the performance of our machine over time, to understand the reliability of our machines over time, we need a good knowledge of data analytics to back up our skills. That is one. The second one is machine reliability skills. And what I mean by that is, how are you qualifying your machine? How are you understanding the variation within your machine? How are you understanding machine to machine variations that is very common in our industry? Anyone with such a skill of understanding how to qualify a machine, how to check reliability of a machine will be highly sought after. The last one is, for me, I feel advanced simulation is very critical. When you look at it from the front end, advanced simulation can help you with your optimization of topology and customizing your geometry. But there is further advanced simulation required when you're talking about the manufacturing side of things. This could be centering simulation. This could be distortion simulation that guides you to succeed when you're printing a part. When it comes to looking for the right candidate, I think with those three, on your resume or with those three skills, you hold the power to a lot of things in our industry. Thank you.
Fantastic. Okay, we've got a lot more questions that have come in and are being upvoted. So our top question right now is, what do you think makes young women in particular such a valuable resource for building the talent pool to fill that gap? What is it that makes engagement with women's organizations so important?
So, oh God, I don't want to be so women, but women are managers. We are natural managers. And when we look at the additive manufacturing roadmaps that company creates, it's a multitasking kind of role where you're thinking about design, you're thinking about printing, you're thinking about post-processing, you're thinking about ensuring that everything just works well. Women naturally can coordinate multiple tasks. And I just feel like women has that creative edge, and we think beyond. We are not just thinking about today. We're thinking about 5 years from now. So when you're looking to scale up additive, you should put a woman there, because she's not only going to be thinking today, she's going to be thinking 5 years down the line. She's going to be bringing her creativity. She's going to be bringing her ability to multitask in there to make sure that every process is safeguarded, and is not only safeguarded for today, but there is a plan for many years ahead.
And if we broaden out from that, if one joined the AM industry right after receiving their bachelor's degree, would you recommend graduate school, or do you think professional experience is more beneficial?
So this is very tricky for me, because I have a PhD and I should tell people go to graduate school. I believe that additive manufacturing is a research and data-driven field. With the experience you get on the shop floor, troubleshooting, designing experiment, understanding the changes that are happening, I believe a shop floor experience could give you everything you need and more than what a graduate school will give you. Because a graduate school can be streamlined to just process development and you learn nothing about design. It could be streamlined to just advanced simulation and you don't learn anything else. On the shop floor, especially when working for smaller companies, you get a chance to do multiple tasks together. You get a chance to learn a lot. And I think most companies would rather take people with experience and just a bachelor's degree than somebody with a master's degree who has no single industrial experience and who can't hit the ground running. So please go get that job and let's go get you that experience.
Perfect. And looking more into joining the industry, what is the best way to engage in AM if you are already in a non-AM industry or role?
I recommend what they call upskilling. So upskilling really can happen when you start from market research. You want to research the market, know what are the skills needed to fill the kind of additive roles that you're interested in. After gathering those skills, prioritize the ones with high severity, the ones that has high demand, and go get them on your resume. And do a good career development plan that helps you transition from non-AM to AM. This is like a little bit of build up. It's not like starting afresh, but you know, in the tech industry, people are self-taught on a lot of things these days. And because we belong to the cohort of Industry 4.0, I believe there are opportunities for you to self-teach or use online courses or use a little bit of buying your own printer and learning different skills that may be very required and valuable to our industry.
Great. Kind of building on that one, we've got a similar question about whether you have any thoughts or suggestions for career progression for non-engineering or scientific roles within AM.
One of the slides that I showed previously covers how AM roadmap should look like, that there is that engineering and very research focused area, and then we move over to the manufacturing areas. Under that manufacturing areas, we have supply chain opportunities, we have data analytics opportunities, we have reliability opportunities, there are project management opportunities. There are so many opportunities that doesn't require you to be able to develop a process within AM. AM is manufacturing. So every pillar that is required to build a manufacturing plant is required to also build an AM plant. So you don't have to be in sciences before you get into AM. You just have to find where exactly you fit. Somebody like Sarah could talk more about that. She's an AM, she's a communication specialist, and she fits right in because there's a place for her. So there's a place for everyone in AM, I believe.
I definitely agree with that. And, you know, personally, my degrees are in theater and English. I had a minor in Spanish. And with that, I've built a career in AM. So I think there's definitely a place for everyone here. And Addie, we've got time for one more question today before we have to sadly end your time here. And I know you're relatively new with Desktop Metal, and congratulations again on the new appointment. We're excited to see what you do there. We have a question about what has been the biggest challenge you have faced during your time in your current role at Desktop Metal.
I've just been there for a month. I wouldn't tell you right now that I have a lot of challenge. I haven't had challenges yet, but I have had highs. Some of the highs is collaboration, how within the company there is huge collaboration, having that open office system where people talk to each other, and using Slack and really being the cool kid of industrialization of AM. So I don't have a low at DM yet. I hope not. But what I have received so far has been innovation, collaboration, extreme knowledge within the teams. And I really look forward to contributing. Unfortunately, no lows, but lows happen in our careers. But when those lows happen, they are our teachable moments. There are moments when we really put into use our engineering skills that says there is always continuous optimization. So our lows should be the point where we deploy continuous optimization and really get to that high point or higher point later on. Well, I know we only have 1 minute left, so thank you, Sarah, for having me.
Thank you, Addie. I know that you're a highlight on our people panel, and I think everyone was very excited to see you today and hear from you. Thank you for sharing your time and your expertise. And I hope to run into you on the networking floor later during the event. Sure. So thank you everyone for joining us. We're going to take a quick break and we'll be back with our next panel on diversity and inclusion in AM.
Thank you all.